Hello good day viewers. In this tutorial we are going to find a solution to this interesting trigonometric equation. The question reads, if tangent x plus secant x is equal to 1.5, we are asked to find sine x, which implies that we are going to treat sine x as a variable, right? So let's get started with the solution. As you all know, we can express tangent x as sine x divided by cosine x, right? So we have sine x divided by cosine x plus, secant x is just the reciprocal of cosine x, which we can write as 1 divided by cosine x. And this is equal to 1.5, and 1.5 is exactly 3 divided by 2, right? So let's simplify the left hand side. Since the denominators are the same, we can write this as sine x plus 1 divided by cosine x. And this is equal to 3 divided by 2. But wait, observe that sine x cannot be equal to -1, because if it is -1 and we have +1 here, the whole of this will give us 0. And the right hand side, you can see, is not 0. And another thing, cosine x cannot be equal to 0 as well, because if it is 0, the left hand side will say to be undefined. So these are the restrictions. Let's continue. From here we can cross multiply. We take the whole of this and multiply by 2. So we have 2 multiplied by sine x plus 1, and this is equal to 3 multiplied by cosine x. And from here I want us to square both sides. If you square the left hand side, let me even write it, 2 sine x plus 1 all squared. This is equal to 3 cosine x all squared. To the left hand side, 2 squared is 4. And if you square this, you're going to obtain first term squared, which is sine squared x, plus 2 multiplied by the first term multiplied by the second term, which is going to give us 2 sine x, plus the second term squared, which is equal to 1 squared, equal to 1. And to the right hand side, we have 3 squared is 9, multiplied by cos squared x. We can express everything in terms of sine x, because cosine squared x can be written as 1 minus sine squared x, right? So instead we have, let me just expand this, we have 4 sine squared x plus 8 sine x plus 4 if you distribute 4. And this is equal to 9 multiplied by 1 minus sine squared x. And to the right hand side, if you distribute 9, we have 9 minus 9 sine squared x. And the left hand side remains the same. Now let us bring every single term to the left hand side. So we have 4 sine squared x. As -9 sine squared x crosses over, it becomes positive as well. We have 9 sine squared x. Then we have plus 8 sine x plus 4. As 9 crosses over, it becomes -9, and this is equal to 0. 4 sine squared x plus 9 sine squared x is 13 sine squared x plus 8 sine x. Then 4 minus 9 is -5. The whole of this equal to 0. Observe that this is a quadratic equation written in terms of sine x. So we can also factorize it. You take the leading coefficient 13, you multiply by the constant -5. We have, let me just write it here, -5 multiplied by 13, which is equal to -65. Now we are going to think of two numbers, which when we multiply them together, we get this negative 65. And when we add them together, we get the coefficient of the middle term, which is 8. The numbers are just negative 5 and positive 13. So what we have here after factorizing, sine x minus 5 divided by the leading coefficient, which is 13. Then multiply by sine x, then plus 13 divided by the leading coefficient, which is 13. And this is equal to 0. By setting each factor to be equal to 0, the first one we have sine x minus 5 divided by 13 equal to 0, or the other one, sine x plus 13 divided by 13 is 1 equal to 0. So by solving these two equations separately, the first one, sine x, is equal to 5 divided by 13, or sine x equal to negative 1. So these are the two solutions we obtained for sine x. But remember, from here we say that sine x can never be equal to negative 1, and hence we are going to discard the other solution here. We don't want this, and hence we are going to consider sine x equal to 5 divided by 13. Remember, we are not looking for x, rather sine x, treating sine x as variable. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.